Hi friends, in this video we see previous year TRB questions from Electromagnetics transmission line and antenna subject. Right, it comes under the category of Electromagnetics. Let us start. The question number one is the velocity of propagation, velocity of electromagnetic waves in a dielectric medium. We know in general the velocity is given by V is equal to 1 by root of mu epsilon. Here it is free space. It is a general formula. For dielectric medium, they have given epsilon r is equal to 4. So that means this implies V is equal to 1 by, they didn't talk about mu, so epsilon r they have given. So this I write as 1 by root of mu naught mu r epsilon naught epsilon r, right? So since it is they don't talk about mu r, so I assume that is 1. So mu r is 1, epsilon r is 4. So 1 by root of mu naught epsilon naught into 1 by root 4 into 1. Epsilon r 1 epsilon r 4 mu r is equal to 1. So 1 by root of mu naught epsilon naught is given by 3 into 10 power 8. Divided by 2, it is 1.5 into 10 power 8. So option B is the right answer. Second question, the reflection coefficient of a VSWR, reflection coefficient and VSWR are related. We know gamma is equal to S minus 1 divided by S plus 1. Right? So this is the correct answer. Next one, if PR is the radiated power and PO is the power dissipated by the antenna respectively, then directivity and gain are related by, so gain is equal to power radiated divided by PO plus PR into directivity. It's a direct formula, so option D is a right answer. Next question, which one of the following does represent Maxwell's divergence equation for static electric field, right? So you see they are talking about static electric field, but the divergence equation. So we know that B is all about magnetic field. Here you see, we know magnetic field won't diverge. When you start from north and go, the lines will start from north and goes and end at the north itself, right? So it is a closed loop. It will rotate, it will curve. Magnetic field is a rotational field. So magnetic field will not diverge. So which is talking about that del dot B is equal to 0. That means the divergence of magnetic field is 0. That means magnetic field only rotate. Magnetic field will not diverge. So option A is a correct answer. What is the Poynting vector has the dimension, right? We know Poynting vector S is equal to E cross H. S unit is volt per meter. H unit is ampere per meter. Volt into ampere is watts per meter square. So option B is a right answer. The relation with which is valid for perfect conductor is dN is equal to 0, because inside a conductor electric field is 0. So dN is 0. Okay. Next one, the intrinsic impedance of a free space. Intrinsic impedance is nothing but a impedance which is phased by a EM wave in free space. Its value is 125 ohms or it is 377 ohms. Both are right. So option D is the right answer. Okay. Next one, the Brewster angle associated with electromagnetic wave propagation is tan inverse of root of epsilon 2 by epsilon 1. Direct question. Next question, the radiation pattern of a HC and dipole in the plane perpendicular to the D is just figure of 8, because we know the what you call, okay, it will be like this, right? The radiation pattern of HC and dipole is like this. It is like a figure of 8. The velocity of EM wave in free space, in question number only I told it is 1 by root of mu naught epsilon naught. 12th question, if A is a width of the waveguide, the cutoff wavelength of TE10 mode propagation, right? So let us see that question. So what they ask, cutoff wavelength. Cutoff wavelength is given by 2 by V into root of m by a whole square plus n by b whole square. Here this 10 talks about m and n. So m is equal to 1, n is equal to 0, right? And substitute all the values. So 2 by 3 into 10 power 8, sorry, 2 by a1, right? So 2 by not b, b is not there. Forget the formula. So 2 by root m is 1, so 1 by a squared, n is 0, so that will give 2a. So option is option A. Okay. Next one, characteristics impedance of your lossless transmission line is root of L by C. Option C is the right answer. Next one, a line leading to a broadcasting transmitter antenna operates at a frequency of 1.2 megahertz. What is the wavelength? We know lambda is equal to C by F. C is T into 10 power 8 divided by 1.2 into 10 power 6, that is equal to 250 meter. So option C is the right answer. Okay. Next question. The electric field lines and equipotential lines are always perpendicular to each other, or they cut each other orthogonally. Right? They must be perpendicular to each other. Next question, the value of a circle, what they ask is, it is a closed line integral dl along the circle of radius 2 pi, r is equal to 2 pi. So what does it mean? It is talking about starting and end point are same, right? So total length is same. This is what closed integral. It is, they told the shape is a circle, right? Since the total shape is a circle, what is the total length traveled? 0 only. Whatever be the thing, it is talking about total length from starting point to end point. Starting point to end point is 0 because it has no starting point, no end point. So option A is the right answer. Next one, the sinusoidally time varying vector field is what type of polarization? First you check whether phase is different. If phase is different, then surely it is not linear polarization, right? Phase is different. That means it's not linear polarized. So the answer, this is wrong, right? Next one, you see whether amplitude is same. If amplitude same, it is amplitude same, it is circular. Whether amplitude same? No, it is not circular. Amplitude different? Yes. If amplitude is different, it is elliptical. So the answer is option A. Next question, I think it is 19. Okay. Yeah. A solid cylindrical conductor of radius R has a uniform current density I. The magnetic field inside a conductor at a distance R from the axis of the conductor is direct question I by 2 pi R, right? Okay. Oh, sorry, it is IR by 2 pi R square. So IR by 2 pi R square. Next question, for an elliptically polarized wave incident on an interface of a dielectric at the Brewster angle, the reflected wave will always be linearly polarized. It is a very important standard question, so the answer is linear polarization. Next one, consider a transmission line which has characteristics impedance of 50 ohm, right? So Z0 is equal to 50 ohm, terminated by the end as J50 ohm. What is the VSWR? If I want to find VSWR, what I have to do? I have to first find gamma value, then only I can find the VSWR. Because VSWR is equal to S is equal to 1 plus gamma divided by 1 minus gamma. Okay, gamma is equal to ZL minus Z0 divided by ZL plus Z0. Substitute the values. ZL is equal to J50 minus 50 divided by J50 plus 50. If you substitute, what you get is this implies gamma, mod gamma only have to find, right? After simplifying this, find the magnitude. You get gamma is equal to 1. This implies 1 plus gamma, 1 minus gamma, that is equal to infinity, right? So this is answer is option C. Next, the quarter wave matching transformer has a 75 source and a 300 ohm load. What is the characteristics impedance? So the characteristic impedance of quarter wave transformer is ZO is equal to ZS into ZL. ZS source impedance 75 ohm, ZL 300 ohm, that is 22500, that is equal to 150 ohm, right? So 150 ohm means the option C is the right answer. Fine. The next question is, the degenerative mode in a waveguide is characterized by same cutoff frequency, different field distribution. The waveguide with such a characteristics is known as the degenerative mode, right? Same cutoff frequency, different distribution. Okay. Next one is a wire of length L, right? So dl is equal to 1 meter, carries a current of 1 ampere at frequency 10 megahertz, that is 10 power 7 hertz. What is the total radiated power, right? So we know total radiated power is given by 40 pi squared divided into dl by lambda whole square. 40 pi squared, dl is 1 meter, lambda is c by f, c is 3 into 10 power 8, f is 10 power 7 whole square. If you simplify, what you get is 0.43 watts. So the answer is option A. The next question, the radiation resistance of Hertzian dipole antenna is 80 pi into dl by lambda whole square. Option A is the right answer. The next question is, an antenna has a 40 ohm radiation resistance, 40 ohm resistance, right? RA. So antenna resistance is 40, right? R radiation is 60. What is the efficiency? So efficiency of the antenna is given by eta is equal to R radiation divided by R radiation plus R antenna. R radiation is 60. This is 60. R antenna is 40. So it is 60 percentage, right? So the option is option D, right? So radiation resistance is nothing but out of total resistance, how much resistance is radiated, right? Okay, that's what this one. Total resistance is radiation resistance plus antenna. This is the one. Okay, next question. A cutoff wavelength for TE20 mode for standard rectangular waveguide, right? So question number 26. Here we know TE20 mode, right? You must remember for standard waveguide, it is A is equal to 2B, right? This is what standard waveguide for formula. So substitute that. Cutoff wavelength is given. What is the thing? Cutoff wavelength. Cutoff wavelength is, we know already, it is 2 by root of m by a whole square plus n by b whole square, then 2 by, see here you see m is equal to T20. So m is equal to 2, n is equal to 0. So root of 2 by a is equal to 2b. So m by a square n 0. So it will be removed. So it is 2 by 2 by a right? So simply it is equal to A. So the answer is option C, A. Okay. Next question. Yeah, 1 kilometer. Okay, length they have given. Yeah, 1 kilometer R. So R is 1 kilometer. That is 1 into 10 power 3 meter. Link uses two antenna, each having a gain of 30 dB. So transmitting antenna has a gain of 30 dB. 30 dB means it is 1000. If you have any doubt, please refer my video on dB, how to convert dB into decimal value. And the receiver antenna also has the same gain, so it is 1000. Right. Power transmitted is 1 watt. Frequency is 3 gigahertz. 3 into 10 power 9. What is the power received? When they ask relating power transmission and reception, use a Friis transmission formula. PR is equal to GT GR, right? PT lambda by 4 pi R whole square. PT 1 watts, GT 1000, GR 1000, lambda is C by F. C is 3 into 10 power 8 divided by F is 3 into 10 power 9. 4 pi into R 10 power 3 whole square. If you simplify, you will get 63.4 microwatts. So the answer is option C. Next question, antennas 40 ohm resistance and 60 ohm. Oh, just now only we have seen it is a repeated option. D is the right answer. Okay. Next, the characteristics impedance of a free space. That's what I told. Characteristic impedance or wave impedance, everything is same. It is 377 ohm or 125 ohm. Okay, sorry. Next, the electric field intensity associated with a plane wave traveling is given by E is equal to E is equal to 10 cos 2 pi into 10 power 70 minus 0.1 pi z. What is velocity of propagation? That is what the question about. So how can we find velocity of propagation? Velocity of propagation is given by Vp. Vp is equal to omega by beta. Omega, this is general formula. It is omega t minus beta z. Omega is 2 pi into 10 power 7. Beta is 0.1 into 10 power 7. So it is 2 into 0.1 pi. It is 2 into 10 power 8. So the answer is option A. Next, in a rectangular waveguide, A is equal to 2B. A is equal to 2B. Find FC for T is 0 to M is equal to 0, so N is equal to 2. Right? At a frequency of 12 gigahertz. Right? A rectangular waveguide for which we have one rectangular waveguide. For that, A is equal to 2B. The cutoff frequency is FC is 12 gigahertz. The rectangular waveguide mode is T02. What is the cutoff frequency for TM11 mode? They are asking. So first we find what is the thing. We have to find what is A and B value. Then only we can proceed. So we know F is equal to V by 2 into M by A whole square plus N by B whole square. So V is 3 into 10 power 8 divided by 2. M is TE02. T02 0. N is 2. B is 2B. Sorry, B A is equal to 2B. So B is B only. So what is the cutoff frequency for this mode? That is equal to 12 gigahertz. So this is equal to 12 gigahertz. These two are equal. Because this is equal to 12 gigahertz. This implies we will get B is equal to 1 by 40. So we know as per the problem A is equal to 2B. So 2 by 40, that is 1 by 20. Now we can find, we got A and B value. When you want to find the cutoff frequency, we need Mn. So here, what they ask cutoff frequency for Tm11. So here M is equal to 1, N is equal to 1, A, B value we know. So this implies F is equal to V by 2, right? M is 1, A is 1 by 20 whole squared, B is 1 by 40 whole square. If you simplify, what you get is 3 root 5 gigahertz, right? So the option, I think it's B. Yes, option B is the right answer. Okay. Next question. The short circuit impedance of a transmission line having characteristic impedance Z0 and a propagation constant gamma is given by Z0 and H gamma L. Direct question. Suppose if they ask open circuit, the answer is Z0 cot H gamma L. If you have any confusion in remembering, for open circuit we have O, so O2O. That you remember. Shortcut. Okay, next one. The quantity E by H is known as Poynting vector measured in. Just now only we have seen it is watts per meter squared. So it is a repeated question. The dominant mode for a rectangular waveguide is TE10 mode. So direct answer. Next, a load having what you call Z0, ZR is equal to 140 ohm is to be connected to a line of 100 ohm by a quarter wave matching transformer, and the ZS means what you call source impedance, right? So ZS of the transformer. That is what the question. So what is that? ZS equal to characteristic impedance. It is ZR into ZS, load and source, right? So RS. Otherwise, you can put RS, right? Okay. ZR into RS. See, the general formula is characteristic impedance is equal to source impedance into load impedance. Here, source impedance 100 ohm, load impedance 140 ohm. So, what we have to do is it is equal to 140 to 100, that is 14,000, right? So option B is the correct answer. Next one, an antenna is located in a city of radio, is a source of radio waves, and how much time it takes to reach town 12,000 kilometers away. So they have given the distance, distance is 12,000 kilometers, 12,000 into meter, so 12,000, this is meter, right? So distance they have given, and what is the time? So we know velocity is equal to distance per time. Now they ask time is equal to distance by velocity. Distance is 12 into 10 power 6, velocity is 3 into 10 power 8, right? So what happens, that will give 4 into 10 power minus 2 or 40 millisecond. So option D is the right answer. And the next question is question number 40. An antenna has an aperture of 2 meters squared. So AE is 2 meters squared effective aperture. The wavelength is 1 micrometer, 1 into 10 power minus 6. What is the directive gain? Right, so that's what they ask. Directive gain G. So D, A is equal to lambda squared by 4 pi into D, right? AE. This implies directive gain GD. You can say GD. GD is equal to 4 pi into AE by lambda square 4 pi AE value you know, lambda value you know. If you substitute, GD will become 8 pi into 10 power 12. So option B is the right answer. Next question, a uniform plane wave is traveling in z direction, has two components of electric field Ex and Ey. If Ex is represented by phi cos omega t, so you see Ex is 5 volt per meter, that is represented by phi cos omega t. What about Ey? Ey is 10, that is so 5 to 5, so it is 10 cos omega t. Phase angle is plus 30, so omega t plus 30. So option D is the right answer. Next question. A uniform plane wave is travels in a vacuum in a frequency at a frequency of 300 megahertz. So F is equal to 3 into 10 power 8 hertz. Fine. Okay. In y direction, what is phase constant? Phase constant beta is equal to what you call omega by Vp. Since Vp is equal to omega by beta. So they have given we want beta value. So beta is 2 pi into f. F is 3 into 10 power 8. Right. So what is velocity? This is b 3 into 10 power 8. So it is pi. So phase constant is 2 pi radian per meter. Right. Okay. And the next question is a wave from a free space fall on a conductive medium having eta is equal to 123, right? A wave from free space. So it is free space. This is conducting medium. A wave coming from here. Conducting medium has eta is equal to 123, right? So let us assume this eta 2. Free space has a impedance of 377 ohm. This is 123 ohm. What is transmission coefficient? Transmission coefficient is tau t, which is given by 2 eta 1 divided by eta 1 plus eta 2. Right? So what will happen? This is simple. Just to substitute 2 into 377 divided by 123 plus 377. If you simplify, it will give 1.508. That is what our transmission coefficient. Right? Okay, so option A is the right answer. So the next question is point charges 30, minus 20 and 10 nanocoulomb are located at this location respectively. The total flux leaving out of a cube of side is 6 centimeter. So these are all located in the cube. So first we draw the cube, right? So cube of side 6 centimeter, 6 meter. Okay, this is cube. First we finish this, right? Okay, so a cube like this. Okay, sorry for the inconvenience. Right, so we have a cube like this, right? Fine. So here you see this is x-axis, right? Totally 6 meters. So this is x-axis, total 6 meters. So it is 3 meter. Backside 3 meter minus 3. Otherwise, this is y-axis. This is 3 meter. This is 3. Z-axis 3 meter 3. Okay. So 30 nanocoulomb located at minus 102. So minus 1, x is equal to minus 1 will be here, y is 0, z will be 2 somewhere here, right? So backside of the cube. So it is 30 nanocoulomb. So here 30 nanocoulomb located backside of the cube, right? Minus 20 located at 0, 0, 0. So minus 20 located at here, minus 20 nanocoulomb, right? Okay, then third one, 10 nanocoulomb located at 1, 5 minus 1. 10 nanocoulomb located at x is equal to 1, y is equal to 5, and z is equal to minus 1 means bottom side here somewhere, right? So 10 nanocoulomb. What is the total flux leaving? So as per the Gauss law, total flux leaving is equal to charge enclosed, right? So what is the charge enclosed? 30 nanocoulomb minus 20 nanocoulomb. So total flux leaving is 10 nanocoulomb. So option 10 nanocoulomb B is the right answer. Fine. Okay. So the next question is, this is very important. A lossless line having a characteristic impedance of Z0 is equal to 100 ohm, load impedance of 200 ohm. What is the reflection coefficient? Reflection coefficient is S is equal to 1 minus gamma divided by 1 plus gamma. So gamma first I have to find. Gamma is equal to ZL minus Z0 divided by ZL plus Z0. ZL 200 minus 100, 200 plus 100, 300. That is 1 by 3. So substitute gamma value here. 1 minus 1 by 3, 1 plus 1 by 3. Right? So what they ask, voltage reflection coefficient. Yes, answer is 1 by 3. Voltage reflection coefficient is 1 by 3. VSW, this is VSWR, sorry, this is VSWR, this is reflection coefficient. If they ask reflection coefficient, it is 2 by 3 divided by 4 by 3, that is equal to 1 minus 1 by 3 is 2 by 3, it is 4 by 3. Okay, so 2 by 4, right? That is 0.5. Okay, so it is not required, you stop here itself because they ask only reflection coefficient. Then the next question is, which of the following statements are true? What is the correct answer? The dominant mode is the mode with the lowest cutoff frequency. That itself a correct answer. No need to worry about other options. In airline, adjacent maxima are found at 12.5 and 37.5 centimeter. What is the operating frequency? We know the distance between adjacent maxima is given by lambda by 2. So lambda by d is equal to 2 maximas are located at 12.5, 37.5. So the distance between them is lambda by 2. So what is the distance as per the this minus this? So 37.5 minus 12.5 is 25 centimeter. This implies lambda is equal to 50 centimeter. They ask frequency. Frequency is equal to C by lambda 3 into 10 power 8, 50 into 10 power minus 12, right? So it is 600, right, megahertz. 600 megahertz. Okay, right? So option B is the right answer. Fine. Okay. Next question. A waveguide acts as a high pass filter. Direct question. right? So transmission line is a low pass filter, waveguide is a high pass filter. It is used to design allow only very high frequency. Next one, the cutoff wavelength in a standard waveguide for TE11 mode, right? So it is question number 49. For TE11 mode, we must know already A is equal to 2B. We know the formula for cutoff wavelength, so lambda C. Lambda C is equal to, what is the formula? We know lambda C is equal to 2 by root of m by a whole square plus n by b whole square. Here TE11, so m is equal to 1, n is equal to 1. So everything we know, A value we know, B value we know, right? So substitute that value and find it. What you get is 0.8944 Armstrong meter, right? So that is the correct answer. Okay, fine. Next question is a rectangular waveguide with dimension A is equal to 2.5 and B is equal to 1 to operate below cutoff frequency of 15.1 gigahertz. Calculate the cutoff frequency for TE01 mode of the waveguide. We have to find for TE01. So m is equal to 0, n is equal to 1. Given epsilon is equal to 4 epsilon naught, mu r is equal to 1. Okay. So they have given some medium, so the velocity will change. Cutoff frequency is given by f is equal to v by 2 root of m by a whole square plus n by b whole square. But here you must see m, n and everything we know, a, b and all, but v will vary because v is not about free space. So first we find v is equal to 1 by root of mu naught, mu epsilon, right? 1 by root of mu epsilon, right? So that is given by mu is equal to mu naught mu r. Mu naught mu r, mu naught mu r is 1. Epsilon is equal to epsilon naught, that is 4 epsilon naught, right? So epsilon they have given. So what is the thing? It is 1 by root of mu naught epsilon naught. Root of 4 is 2, so it is 1 by 2. 1 by root of mu naught epsilon naught is 3 into 10 power 8. So that is 2, 1.5 into 10 power 8. Now we found everything we have known already. So Fc is given by, so Fc is equal to 1.5 into 10 power 8 divided by 2, right? So what is m value? M0, n is 1, b is 1, so 0 square, 1 square, 1, what is the value? A is equal to 2b centimeter. So A, B are in centimeter. Okay, A and B are in centimeter. So we have to just run far away. 1 into 10 power minus 2. You have to convert into meter. So that will become 7.5 gigahertz. Option B is the right answer. Right? Okay. Next question. An antenna has a maximum radiation intensity is 10 watt per steradian. Average radiation intensity is 4.5 watt per steradian. Eta is equal to 95%. Eta is equal to 95%. What is the input power? So we have to find input power, right? We know eta is power radiated divided by power input, right? We know we have to find power radiated. From that only we can find power in. Okay, so first we find power radiated. Power radiated is given by P radiation is, we have known the relationship U max. Maximum radiation is power radiated divided by 4 pi This implies power radiated is equal to U max. U max is equal to 10, right? So U max into 10 into 4 pi, so 40 pi power radiated, right? Now we know power radiated. What we want is power in, right? So power in is equal to P radiated by P in. Fine. Okay. So what is okay? Sorry. U, it is not U max. It is U average. The formula I wrote as wrongly. Please U average. Average radiation intensity is P radiated by 4 pi P radiated. So this implies P radiated is average is 4.5 into 4 pi. Right? Please forgive me. Then eta is equal to what do you call P radiated by P in. This implies P in is equal to P radiated by eta 4.5 into 4 pi divided by eta is 95%, 0.95. So Pn is equal to 59.52. So 59.52, option D is the right answer. Next question, at what frequency a wave must propagate for the D region to have an refractive index of 0.5, given n is equal to 400 electron per cubic centimeter, that you convert into meters. So 400 into 10 power 6 meter cube, because meter cube is equal to cubic centimeter divided by 10 power 6. So 1 cubic centimeter is 10 power 6 meter cube. That's what we have done. Okay, and so what is the formula? We know n squared is equal to 1 minus et1n by f square. This implies f is equal to f is equal to 81n divided by 1 minus n square. So 81 into 400 divided by 1 minus n, right? So f they have given, whether they have given f or n only they have given. So n is equal to 0.5. N is equal to the refractive index 0.5 square. If you simplify, what you get is it is f squared. What you get is it is 207.84. So the answer is option C. A simple problem. Just you must know this conversion. And n squared is equal to 1 minus 81 by f squared. Okay. 54. What is the question? What is the critical frequency for reflection at a vertical incident? Is the maximum value of electron density is 1.24 into 10 power 6. Okay, they ask Fc value. Fc we know 9 into root power root n. So what they are sorry, they ask critical frequency only. So 9 into 1.24, n is electron density, into 10 power 6, right? So here you see centimeter per cubic centimeter cube, or per cube. See 1.24 into 10 power 6 divided by cubic centimeter. That's what CCM. Already we know we have to convert into meter cube. So meter cube is equal to CCM divided by 10 power 6. So I want to convert into meter cube. So into 10 power 6, right? So that we have to multiply. So what you get is ultimately, if you simplify, you will get 10.02 megahertz. Fine. So the only thing you must remember about the problem like this is centimeter cube means per ccm. That's what cubic centimeter, right? So the answer is option C, cubic centimeter or centimeter cube. Next, the magnitude of the H wave is 1 ampere per meter. What is the E in free space? We know in free space E by H is equal to 377 ohm. H they are given, so E is equal to 377 volt per meter. From this, the answer is option A, 376.8. Next question, a wave in a plane wave as an average Poynting vector is given by P average is 1.5 watt per meter square. What is average energy density? They ask average energy density, W is equal to 1 by 2 epsilon E square. So what is average Poynting vector? P is equal to E squared by 2 eta. This is what average Poynting vector. This implies I want E squared, so E squared is given by P average into 2 eta, P average 1.5, 2 into eta is wave impedance 377 ohm. Okay, so it will give E squared is equal to 1131. So W is equal to 1 by 2. Epsilon is 8.854 into 10 power minus 12 into 1131. If you simplify, you will get 5 nanojoule per meter cube. So the answer option is right. Okay. Next one, the divergence of a curl of a vector. What they ask is divergence. Divergence means del dot. Curl of a vector, let us assume the vector is A. So del dot del cross A. This is what? This is divergence. Curl of a vector is del cross A. Del cross A is nothing but curl of A. Curl of vector A, divergence. We know divergence means spreading, curl means rotating. This is asking how much a rotating vector is spread. Whether a rotating vector will spread? No. The answer is option A. Right? So this is what the divergence of curl of vector. So del dot del cross A is equal to 0. Next question, question number 58. The characteristic impedance of a transmission line, lossless transmission line is given by, already we know it is root of L by C. Image theory we studied only in electrostatics, so answer is option A. Okay. Next question, what is the relation between the electric field intensity E and voltage applied V and distance between the plates of a parallel plate capacitor? We know it is equal to E is equal to V by D. Right? So it's a direct question. Which one of the following is true for a value of the capacitance between two spheres whose separation is very much larger than radius? So it is a direct question. 2 pi epsilon naught r. So value of the capacitance when separation is very much larger. Okay. Okay. Next, capacitance between two spheres. This is a direct question. Next one, 62. The inductance of a solenoid is 10 turns. Solenoid of 10 turns is 5 microhenry. Which of the following is correct if inductance when the number of turns is 20 and length doubled? First we must know what is L. L is equal to mu n squared A by L, which is where n is equal to 10. So for 5 microhenry, mu n is equal to 10 means it is 100. 10 squared A by L. Right? What is the new inductance they ask? What is the value of inductance if when the number of turns is 20? So let us assume L1 mu, that is not changed, n becomes 20, so 20 squared 400. A is not changed, area, length double 2L. So what happens? 20 squared, right? So 20 squared. Okay. Now what will happen? This is 5, so mu into 100, so 4 into mu 100 A by L divided by 2. 4 by 2 is 2, mu AL by mu 100 AL by L is 5, so that is 10. Mu 100 A by L is 5, so the option A is the right answer. Fine. Consider the following equation. Which of the above are Maxwell's equation? Del cross E is equal to minus dou B by dou T, Faraday's law. Maxwell's equation. Del cross H is equal to J plus dou D by dou T. It is modified Ampere circuit law. Okay, Faraday's equation. Del cross B 0? No. Right? So now it is not a 0. It is wrong answer. Only del dot B is equal to 0. Del cross H is equal to JC plus JD. If you make it multiply by mu both sides, it will become del cross B is equal to mu JC plus mu JD only, not 0. So this is not right. 1 and 2 are right. Okay. Next question, the relationship between electric field and electric potential is given by E is equal to minus del V. Sorry, E is equal to minus del V. Fine. Current flow in a dielectric is due to displacement current. Very, very important. Current flow in conductor is due to conduction current JC. This is called conduction current. Current flow in dielectric is due to displacement current JD. Okay. Next question, a circular coil of radius 2 meter carries a current of 4 ampere. So radius 2 meter, I is 4 ampere. What is the value of magnetic field at the center? H is equal to I by it is I think it is I by 2A. So I is 4 ampere, 2 into A is 2. So it is 1 ampere per meter. I in ampere, area in meter. 2A is meter. So 1 ampere per meter. The following law relates the forces experienced by two loops of wire carrying current. Newton's law never. Gauss law is talking about electric field, not about current. So it is not right answer. Coulomb's law is force between two charges. Ampere's circuit law relates forces experienced by two loops of wire carrying current. Okay. Next one, question number 68. Okay. So the next question is a uniform surface charge of rho is equal, sigma is equal to 2 coulomb per centimeter square. Sigma is equal to 2 coulomb per centimeter square. Sorry, coulomb per meter square is situated at Z is equal to 2. What is the value of electric field at P is equal to 1, 1, 1. Right? So this is what they ask. We know it is a surface charge. Surface charge distribution is independent of location. Right? Rho s is given by E due to rho s is given by sigma by 2 epsilon naught. Right? Sigma by 2 epsilon. So sigma is 2 divided by 2 into epsilon naught, otherwise you can put 8.854 into 10 power minus 12, right? So the answer is somewhat wrong, I feel, right? It is 10 power 2 into 2 by 2 is 1.1 into 10 power 12, right? So there is something wrong in this problem, so let us skip this. Okay. Next question is the magnitude of a Lorentz force experienced by a charge moving charge q moving with velocity v in a magnetic field is given by this Lorentz force equation. F is equal to qv cross p. The electric flux inside a conducting sphere is it is always uniform. That we know. Direct question. Okay. 71. What is the capacitance of a capacitor having a stored energy of 10 microjoule? So energy stored is E. Right, it is 10 into 10 power micro 6 joule, right? So what is the C value? We know energy is given by energy stored by a capacitor is 1 by 2 CV squared. This implies 10 into 10 power minus 6 is equal to 1 by 2 into C. V is 5 volt, so 5 squared. If you simplify, what you get is C is equal to 0.8 microfarad. So option B is the right answer. Next one, use question. A point charge of Q is equal to 4 pi epsilon naught coulomb is located at origin. What is the electric field at point 001? We know electric field is given by Q by 4 pi epsilon naught. Okay, the scalar Q they have given 4 pi epsilon naught divided by 4 pi epsilon naught. So it is 1 volt per meter. So the answer is 1 volt per meter. Next question, the antenna is synonymous with the transducer. It is converting electrical energy into electromagnetic energy, so it is a transducer. A open circuit line has a what you call as an input impedance of 0. Direct question, right? Next question, the reflection coefficient is 1 by 5. What is VSWR? We know VSWR is equal to 1 minus gamma divided by 1 plus gamma. 1 minus 1 by 5 divided by 1 plus 1 by 5. 4 by 5. This is 6 by 5. Right? Sorry, S is equal to 1 plus gamma divided by 1 minus gamma. S is equal to S is equal to some problem. S is equal to 1 plus gamma divided by 1 minus gamma. 1 plus 1 by 5 divided by 1 minus 1 by 5. 6 by 5 divided by 4 by 5, that is equal to 1.5. So option B is the right answer. Next question. A lossless transmission line having what do you call lossless transmission line having a 50 ohm characteristics impedance. So Z0 is equal to 50 ohm, right? And L is equal to lambda by 4. Short circuited at one end. So Zin 0. Connected to ideal voltage source of 1 volt at the other end. What is the current run from the source? What is the S value? So you see 50 ohm characteristic impedance and they are having connected and input impedance is 0, so it is a quarter wave line, right? 50 ohm characteristic impedance. So for quarter wave line, it is a quarter wave line. So Z in is equal to ZO squared by ZL. This implies ZL load impedance is ZO squared divided by Zn. So it is Zn is 0, so it is infinity. Fine. So ZL is infinity. I is equal to Vs by. See, they are asking what is the current at the other end, right? Current run from the source. So what you get is you can get Vs is 1 volt, ZL we know it is 0. Sorry, load impedance is as per the question it is short circuited at one end, right? So short circuited at one end means other end only, not from source end. So what you call it is short circuited at the one end. So ZL is 0, right? So please change here. Okay. So read the question properly, otherwise you people also will make mistake like me. So this implies Zn equal to what is the thing happening? ZO square divided by ZL, that is infinity, right? Okay, Zn is this ZL is equal to 0. It is shorted at other end, not from the source end. So I is equal to source current. They are asking current run from the source. Is equal to Vs by Z in V by R. Vs is 1 mode, Z in infinity, so it is 0. So the answer is option A. Next question, a transmission line whose characteristic impedance is purely resistance, it may be or may not be a lossless line. So option C is the right answer. Ground wave must be vertically polarized, this we know directly. For a transmission line, load matching over a range of frequency, it is best to use always double stub, right? Okay. Next question, if a transmission line is terminated with a load equal to characteristic impedance reflection coefficient. So ZL is equal to Z0. Reflection coefficient is given by ZL minus Z0 divided by ZL plus Z0. ZL is equal to Z0 means it is 0. So option C is the right answer. Next question, short-term fading commonly observed in, we know it is directly a troposcatter communication only, we can observe it directly. Okay, in the end-fire array with antenna spacing of lambda by 4, the elements are fed with 90-degree out of phase. These are all direct questions, so in end-fire array, it is the elements are 90-degree out of phase. Well-known question. Next question, a field is solenoidal, right? So a field is solenoidal if divergence is 0. Please remember, this is very important. If vector is A, so the divergence of vector is 0 means it is solenoidal. If curl is 0, it is irrotational, right? So if divergence is 0, if curl is 0, it is irrotational. Fine? Okay. Next, the basic principle of impedance matching is, we know it is always maximum power transfer theorem. Next one, the radiation resistance at the terminals of the antenna is given by R is equal to 120 by divided by naught squared integral h squared ds. Direct question. Next question is, okay, so it is question number 86. The reflection coefficient of the wave with VSWR 3.5. So S is equal to 3.5. Right, that's what they have given. So we know gamma is equal to S minus 1 divided by S plus 1, 3.5 minus 1 divided by 3.5 plus 1, 2.5 divided by 4.5, that is equal to 0.55. So the option A is the right answer. Fine. Okay. Next question. Oh, fine. This is if all the physical dimensions of the antennas are reduced by a factor of 2 and the wavelength is increased by the factor of 2, then performance of the antenna will remain still unchanged only. Fine. Okay. Because all the factors means you have to take all the factors. They are all inversely proportional to lambdas. When lambda increases by a factor of 2, so total remains unchanged. In broadside array, the maximum radiation can be achieved when all the elements are fed with similar amplitude and similar phase also. So option B is the right answer. Okay, very important. Next, according to Biot-Savart law, the magnetic field intensity, we know Biot-Savart law states H is equal to IDL divided by 4 pi r square into cos r cap. So it is R is the distance between source and the field point. Okay, so the option, it is inversely proportional to the square r square. So inversely proportional to the square of the distance. Similarly, Coulomb's law is also inverse square law. Q1 Q2 divided by 4 pi epsilon naught r square into r cap. So this is also inverse square law. Next question. ZL is equal to 200. Z0 is equal to 50. What is the, then the quarter wave transformer should have a characteristic impedance. Characteristic impedance of quarter wave transformer is ZL into Z0. Sorry, ZL into ZS or source impedance. So ZL as per the problem 200. Source impedance or input impedance is 50. So that is equal to 100 ohm. So the option is B. Right? So simple problem. And the next question is, what is 92? A rectangular waveguide in dominant TE10, so M is equal to 1, N is 0, has a dimension of A 1.07 into 10 power minus 2 meter, B 0.43 into 10 power minus 2 meter. What is the cutoff frequency? We know Fc is equal to V by 2 root of M by A squared plus N by B squared. Simplify it, right? A B value, where V is 3 into 10.8. So A B value we know, Mn value we know. If you simplify, we get 9.72 gigahertz as answer. So option A is the right answer. Next one, what is 1293? Which one of these equation is not Maxwell's equation for static electromagnetic field? Okay, delta B 0, Gauss law for magnetic field. Okay, d dot ds is equal to q, Gauss law for electric field. Del cross E, delta D is nothing but del cross E is equal to 0. That is also okay. Del squared A is mu naught J. This is not Maxwell's equation, right? This is Poisson's equation for magnetic field, right? So this is Poisson's, it is minus mu J will come, please remember. Minus mu J means Poisson's equation for magnetic field. So this is the wrong answer. Okay, the concept of displacement current was a major contribution attributed to Maxwell's. What is displacement current? It is current due to field, not due to charge. Current due to charge is conduction current. It is due to charge. Okay, which of the modes doesn't exist in resonant cavity? It is T110. Next question. Find the radiation resistance of an infinitesimal dipole of overall wavelength. It is overall length of lambda by 50, not p by 50. It should have been lambda by 50. We know our radiation is 80 pi squared into dl by lambda whole square. 80 pi squared, right? Lambda overall length 1, right? 1 is dl is lambda by 50. Okay, dl is lambda by 50 into lambda, that is square. So it is 80 pi square divided by 2500, right? Overall length is this piece. It is overall length is equal to lambda by 50. Sorry, dl is equal to lambda by 50. That's what I have substituted here. Okay, so if we simplify, our radiation will be equal to 2 point something. It has come, right? It is 2 point okay, 0.316, right? 0.3156, that is 0.3155. You got it. So convert it to 0.316, right? So option A is the right answer, right? Here the question you have to change, whose overall length is not 1, is overall length is lambda by 50. Fine. That's all about this session. I hope you understand every problem. If you have any doubt, please ask me in comment section. I will clarify. Thank you.